So now units and dimension. To see the question number 1. In the question number 1, the question is that the number of significant figure in a measurement of 1.887294 into 10 to the power 8 meter per second is. The option are, first option is your 8, second option is 7, third option is 15 and fourth option is 6. Now the measurement is that, see the solution of this. As per the given data, our measurement is 1.887294 into 10 to the power 8 meter per second. So as we know, when we are calculating the significant figure, so any power raised over 10, those are not taken as a significant figure, and all the non-zero are our significant. So this is not counted as a significant. So all other zeros, non-zero numbers are significant figure here. The total numbers are 1, 2, 3, 4, 5, 6, 7. The total significant figures are 7. So our answer is 7. 7 significant figure. 7 significant figure. So correct option is the option number 2. The option number 2 is the correct answer. Now come to the question number 2. Question number 2. Question is this: while measuring length of an object, it was observed that the zero of the vernier lies between 1.4 and 1.5 of the main scale, and the fifth division coincide with the main scale division. If the length of the object measured is your L, then the value of L minus 1.4 in terms of the least count C of the instrument. And our options are, first option your C, second option your 1.45 C, third option are 4 C, and the fourth option is your 5 C. See how we are measuring the, or how we are taking the reading from the vernier calipers. When we are considering the vernier calipers, so our reading is taken like that. First we will see the zero of our vernier calipers and see the zero of vernier scale where it lies. As per the question here, it lies between 1.4 to 1.5. So this is your 1.4 reading and 1.5. It means somewhere here zero of vernier scale is lying. So reading will be your 1.4, that will be greater than 1.4 and less than 1.5. So 1.4 plus. After that we will check this zero of vernier scale coincide which of the division of main scale. So as per the given question here, if fifth division coincide with the main scale division, so 55 into least count your C. So this is the actual reading. The L is equal to 1.4 plus 5C is the actual reading. So as per the given question here, L minus 1.4, that will be equal to your 5C. The 5C is our correct option. So option number is your, so answer is 5C. So correct option is your option number 4. So option number 4 is our correct option. Now come to the next question, question number 3. Question number 3. Question is that if the acceleration due to gravity is 10 meter per second square and the units of length and time are changed in the kilometer and hours respectively, then the numerical value of the acceleration is given as. The first option your 36 into 10 to the power 4, or we can say 360,000. Second option is your 72,000, and third option is your 36,000, and the fourth option your 129,600. So we have to select the correct option. Now see how to solve this problem. See, as we know, G value is given as 10 meter per second square, and now this G value we would like to change in the kilometer and hours. See, if we want to change in the kilometer and hours, so 1 kilometer is equal to your 10 to the power 3 meter. So we can say 1 meter is equal to your 10 to the power minus 3 kilometer. Similarly, 1 hour is your 3600 second. So 1 second is equal to your 1 by 3600 hour. In this manner we would like to convert it. So see here, this is your 10. Here it is meter. So that 1 meter we can write here 10 to the power minus 3 kilometer by second square. Second square, that we can write 1 by 3600 square, and this become your hour square. Now when we are further simplifying this, so 10 into 3600 square into 10 power minus 3. So this is your 36 into 36 into 10 to power 5 into 10 power minus 3. So that will be your 36 into 36. We can make a calculation here. So 36 into 36, 216 into 108, 6912. So this will be your 1296 into 00. So this is the value of G, kilometer per hour square. So this is the final value of G we are getting, 129,600 kilometers per hour. So this is our answer, and as per the given option, option number 4 is the correct. So hence we can write answer your option number 4. Option number 4 is the correct option. Now come to the next problem, problem number 4. Question number 4. Question is that if L, C and R represent inductance, capacitance and resistance respectively, then which of the following does not represent dimension of frequency? So first option is your 1 by RC, second option your R by L, third option your 1 by root over LC, and the fourth option your C by L. So one by one we would like to check it, all the options here. Now see. So here it is given LCR. So LCR. So one by one all dimension we will find. See, dimension of L. As we know, L is defined as magnetic flux per unit current here. So flux by I, and that flux we can write magnetic field into area by I. Magnetic field further written as F by IL. S is your L square by I. F further we can write M L T minus 2 L square by A square L. So simplified this one, we can write m L square T minus 2 A minus 2. So, this is the dimension of L. Now, similarly, dimension of C written as Q by V, and Q is the charge. Charge is your written as first V we can write V is your W by Q. W is the work done. Now, Q is square by work done is your force into displacement L. So, this one Q is AT, A square T square, and F is your ML square T minus 2. So, dimension of C m minus 1 L minus 2 T to the power 4 A minus A plus 2. So, this is the dimension of C. Now, when we are looking the dimension of R, dimension of R is your dimension of V by I. V is your W by Q. So, W by Q, Q is your I into T, so I square into T, and W is your M L square T minus 2 A square T. So, finally, it will be your M L square T minus 3 A minus 2. So, this is the dimension of your R. So, after getting all dimension, now check the first option. First option your 1 by RC. 1 by RC. So, 1 by R into C. When we are making R into C, M and M cancel, L square cancel, T left only, A and A cancel, only T left. So, this is the dimension of your frequency. So, this represent your frequency dimension. Similarly, if we are looking the second option R by L, see R by L. R by L, when we are doing, this will cancel, this also cancel, R by L T minus 2, this also cancel. So, we can get here T minus 1. So, this is also the dimension of frequency. Now, we will see the third option 1 by root over LC C. So, when we are looking root over LC, product of L into C, product of L into C, this cancel, this also cancel here, T square left only, this is T square, this is also T. So, all these three represent dimension of frequency. But when we are looking the fourth option C by L, C by L, dimension of C is M minus 1, L minus 2, T4, A2, and dimension of L, M L square, T minus 2, A minus 2. Now, check it. This is the dimension of M minus 2, L minus 4, T6, A4. So, this is not the dimension of your frequency. So, option 4 does not represent dimension of frequency, does not represent dimension of frequency. So, answer is your option 4 is the correct option. Now, come to the next question, question number 5. Now question number 5. Question is this: the number of particles is given by n is equal to minus d n2 minus n1 x by x2 minus x1 crossing a unit area perpendicular to x-axis in unit time, where n1 and n2 are the number of particles per unit volume for the value of x, mean to x2 and x1. Find the dimension of d, called as diffusion constant. The option first is your m to the power 0 L t minus 2. Option second is your m0 L square t minus 4. Option 3 is your m0 L t minus 3. And option 4 is m0 L square t minus 1. So now see how to solve this one. As it is given here, n is equal to your minus d n2 minus n1 by x2 minus x1, where n is the number of particles per unit volume. And see, let this your any x-axis, and if we are considering any area here, so n represent the number of particles crossing per unit area. N is your number of particles crossing per unit area. So dimension of n will be your dimension of your per unit area means L minus 2, while n2 and n1 are number of particles per unit volume for the value of x2 and x1. It means from x2 and x1, here let x1 and x2, the number of particles passing per unit volume. So dimension of n2 and dimension of n1 will be the same as the number of particles passing per unit volume, and this is your per unit area per second also. So in case of per second, t minus 1. And now x2, dimension of x2 will be your dimension of x1, which is your L. Now substitute these dimension over here. So now when we are substituting these dimension, all value we can substitute here. Check it. Dimension of n here L minus 2, t minus 1. Dimension of d we have to find. Now dimension of this here L minus 3. Dimension of this here L. So check it, the dimension of d. So dimension of d, there is no factor of mass m naught. Now this becomes L to the power minus 4. When it comes here, it becomes your L square and t minus 1. So dimension of d is your m to the power 0 L square t minus 1. So this is the dimension of diffusion constant, and as per our option 4 is the correct option. So answer is your option 4 is our correct option. Now come to the next question, question number 6. Question number 6. Question is that x is equal to your 3yz square. Find the dimension of y in the system if x and z are the dimension of capacity and magnetic field respectively. And the option is first is here m minus 3, L minus 2, t minus 4 and a minus 1, while the option 2 is here ml minus 2. Option 3 is m minus 3, L minus 2, t to the power 4 e to the power 4, and option 4 is m minus 3 l minus 2 t to the power 8 and 8 to the power 4. Now see how to do this problem. As per the here, our expression is given x is equal to 3 yz square. X is equal to your 3 yz square, where y is the capacitance and z is the our magnetic field. Z is your magnetic field, where x is the capacitance and z is the magnetic field. So our expression is x is equal to 3 yz square, where x is the capacitance and z is the magnetic field. So we have to find dimension of y. So from the given expression we can write dimension of y is nothing, that is the dimension of x by dimension of z square. First we would like the dimension of x. So dimension of x, capacitance. Capacitance is written as we know one relation, C is equal to Q by V. So Q by V we can write, and V is your W by Q. So dimension of Q is your A square, T square, dimension of Q square, and dimension of work done here M L square T minus 2. So we can say dimension of capacitance is your M minus 1, L minus 2, T to the power of 4 A square, while dimension of Z. Z is the magnetic field. Magnetic field, one relation is given F by IL. Dimension of F, MLT minus 2. Dimension of I current, A, L. So this become M T minus 2 A minus 1. So this is the dimension of Z. Now we can substitute over here. So dimension of x, M minus 1, L minus 2, T4 A square, while dimension of Z is square of this. When we are making a square of this, M square, T minus 4, A minus 2. So finally dimension of y will be M minus 3, L minus 2, T to the power 8, A to the power 4. So this is the dimension of our expression y. So as per the given option, option number 4 is the correct option. So we can say answer 4 is the correct option. So this is the question number 6. Now come to the next question, question number 7. We now see the question number 7. In the relation P is equal to alpha by beta e to the power minus alpha z by k theta, where P is the pressure, Z is the distance, K is Boltzmann constant and theta is the temperature. The dimensional formula of beta will be, option number 1 is m to the power 0 L square T0. Option number 2 is m1 L square T1. Option number 3 is m to the power 1 L0 T minus 1. And option 4 is m to the power 0 L square T minus 1. Now see how to do this problem. So first of all, it is given pressure P is your alpha by beta e to the power minus alpha z by k theta, e to the power minus alpha z by k theta here. This is our expression is given here, where P is the pressure, P is given pressure, Z is given here distance, K is Boltzmann constant, while theta is given as a temperature. Now we would like to find the dimension of beta. See, as we know, exponent does not have any dimension. So whatever the dimension of Lz by k theta, that will be your m to the power 0, L to the power 0, T to the power 0, all this. So dimension of alpha z by k theta will be your m0, L0, T0, and whatever the term, that all will be your 0. So from that we can get the dimension of alpha. So dimension of alpha is equal to your dimension of k, dimension of theta, and dimension of z. So how to determine the dimension of k? K is here Boltzmann constant. As we know, energy of a molecule is also given as 3 by 2 kT. This is the energy. Energy of molecule is given as 3 by 2 kT. The dimension of energy we know m L square T minus 2. This is dimension of k, and T is your temperature. So that will be the dimension of as theta. So dimension of k. Dimension of k is written as m L square T minus 2 theta minus 1. This is the dimension of k, that we can substitute here. See then, the dimension of alpha is dimension of k, m L square T minus 2 theta minus 1. Then dimension of theta is the temperature, that is theta, and dimension of z is your length L. So this become your m L T minus 2. This is the dimension of alpha. Next is this is your dimensionless. Now the P is the pressure. Pressure having same dimension as the dimension of alpha by beta. So dimension of beta is equal to your dimension of alpha by dimension of P, any pressure. Alpha dimension as we know ml T minus 2, and pressure your force per unit area. So force dimension your ml T minus 2 per unit area. So we can divide with the area. The area means L square. So finally we can say dimension of your beta is L square. So as per our given option, so dimension of your beta is L square. So we can say dimension of beta is nothing, dimension of your m L square and T0. So as per the given option number 1 is the correct option. So hence we can write our answer is your answer number 1. And the first option is the correct option. Now come to the next problem, question number 8. Now question number 8 is the frequency of vibration of a string is given as nu is equal to P by 2L F by m to the power 1 by 2, where P is the number of segments in the string and L is the length. The dimensional formula for m will be? The first option your m to the power 0, L t minus 1. Second option your m L is 0, t minus 1. Third option your m L minus 1 t 0. And the fourth option your m 0, L 0, t 0. Now see how to solve this problem here. So solution is that nu is given as p by 2L under root f by m. This is the relation for frequency. Now p is the number of loops. This is a simple number. L is the wear length. F is here force, and m dimension we have to find. And nu is the frequency. Dimension of frequency. Dimension of frequency or t to the power minus 1. Dimension of number of loops, this is number, that will be your no dimension. L is the length, 1 by L. This is dimension. Now dimension of force. Force is your ml t minus 2. And this dimension we have to find. So 1 by 2. And dimension of 1 by m we have to find. Now check it how to get this one. So from here we can write here L square t minus 2. If we are squaring both the side, that will be your ml t minus 2 by dimension of m. So our dimension of m is equal to your ml t minus 2 by L square t minus 2. So this become your m L minus 1. So this is the dimension of m. So from here we can say, if we will see our options, see the dimension of m is your m L minus 1, and in all form if we want to write m L minus 1 t 0. So as per the given option, option number 3 is matches with the whatever the result we have found. So correct answer is your answer number 3. So answer number 3 is the our correct option. Now come to the next question, question number 9. Now question number 9. A wire has a mass 0.3 plus minus 0.003 gram, length 0.5 plus minus 0.005 millimeter, and the length is 6 plus minus 0.06 meter. The maximum percentage error in the measurement of its density is, first option your 1, second option is 2, third option is your 3, and the fourth option your 4. Now see how to solve this one. First we would like to write the data whatever the given mass. Mass is given 0.3 plus minus 0.003 gram. 0.003 gram, this is the mass. Now radius. Radius r is given here 0.5 plus minus 0.005 millimeter. 0.5 plus minus 0.005 millimeter is the radius. Length. Length is given here 6 plus minus 0.06 meter. 6 plus minus 0.6 meter. This is the length given, 0.06 meter given. Now they are asking what is the percentage error in the density. As we know, density is equal to density rho is equal to your mass m by volume v. Mass m, volume we can have area into length L, and wire just like a cylinder. So area is nothing here, pi r square into L. So percentage error in the density. So percentage error in the density, this is nothing, percentage error in the mass plus 2 times delta r by r into 100 plus delta L by L into 100. This relation we can use to get the error in the density. Now substitute the value. Delta m, change in the mass, 0.003 by mass m, 0.3. 0.003 by mass 0.3 into 100 plus 2 times delta r, change in the radius or error in the radius, that could be your 0.005 by 0.5, 005 by 0.5 plus similarly percentage error in the length, 0.06 by 6, 0.06 by 6 into 100. Now we can simplify this. When we are simplifying, this become your 1, and when we are simplifying this become your 2, and when we are simplifying this become your 1 again. So total is your 4. So percentage error in the measurement of density is your 4%. So our correct option here, answer number 4 or option number 4 is the correct option. Now come to the next question, question number 10. Question number 10. Question is this: if 97.52 is divided by 2.54, the correct result in terms of significant figure is. So first option your 38.4, second option your 38.3937, third option 38.394, and the fourth option your 38.39. So our division, it means we have to divide 97.52 by 2.54. 2.54. First of all, according to the significant rule, whenever we have to use the division or multiplication, so all the division and multiplication, our answer should be in terms of those number which are having least number of significant figure. So in this expression, 2.54 have significant figures are 3, 97.52 have significant figures are 4, the least significant figures are 3. So unnecessary we will calculate, directly we can say in the given option, option number 1. Option number 1 have 3 significant figures, but rest of the other option have more than 3. Then our total number of significant figures should be your 3 in the final answer. So option number 1 is the correct. So answer is your 1. That is the correct option here, in which number of significant figures are 3. Come to the next problem, problem number 11. Now see the question number 11. The question number 11, the surface tension of a liquid is 79 per centimeter. So in MKS system its value is, option first here 70 Newton per meter, option second is your 7 into 10 power minus 2 Newton per meter, third is 7 into 10 power minus 3 Newton per meter, and the option 4 is 7 into 10 power 2 Newton per meter. see how to calculate. It is given the surface tension as that is 79 per centimeter. Surface tension given here. Normally we are representing with a S 79 per centimeter. Now this is your CGS unit. This we have to convert into SI. So in case of surface tension definition, surface tension is nothing, it is a force per unit length, and force is your, we can write here, mass into acceleration by length, and acceleration is your mass into acceleration, we can say length per second square into length. In fact, this is the relation for your surface tension. Now from here we can calculate that your 79 per second per centimeter. So this whole term can be written as a dyne. Dyne is also unit of the force which is in the CGS system. So in the CGS system, mass in the gram, length in the meter, that is in the SI system, and we can convert in the dyne. Dyne means mass in the gram, so we can convert mass gram into kg. 70 mass in the gram in CGS system. So if we have to convert into SI, so 1 gram means 10 power minus 3 kg. Next, length. Length in CGS system in centimeter. Convert into meter. So 10 to the power minus 2 meter. Second square will remain as it is. Again length. Length in centimeter in the CGS system into minus 2 meter in the SI or MK system. Now check it here. So whole relation will be your 70 to 10 power minus 3 kg meter per second square, kg meter per second square by meter. So this is nothing, 17 to 10 power minus 3 Newton per meter. This is in the SI system or in the CGS system. So finally we can say surface tension into SI system is written as 7 into 10 power minus 2 Newton per meter. This also can be said in the MK system. So our correct option is the option number 2. So hence option 2 is the our correct answer or option. Now come to the next question, question number 12. The question number 12. The unit of permittivity of free space epsilon naught is, option number 1 is Coulomb per Newton meter, option 2 is Newton meter square per Coulomb square, option 3 is Coulomb square per Newton meter square, and option 4 is Coulomb square by Newton meter square. So now check it, see. We have to find unit of electrical permittivity in the free space. So one relation we are having related to electrical permittivity, as we know, when the two charges are kept at a certain distance, the force of attraction or repulsion between them is given as 1 by 4 pi epsilon naught Q1 Q2 by R square. Here epsilon naught is the electrical permittivity. So epsilon naught can be said as 1 by 4 pi Q1 Q2 by F into R square. This is your constant. Here this is your charge. Q1 and Q2 charge. So unit of charge. The epsilon naught unit of charge is your, you can see, Coulomb square. Then F is the force. Unit of force is your Newton. R is the distance, that is the meter. So Newton and meter square. This is the epsilon naught unit. So unit of epsilon naught is Coulomb square by Newton meter square. So as per the given option, our option number 4 is the correct option. So we can write answer 4 is the correct answer. Now come to the question number 13. In the question number 13, capital E, small m, L and G denote energy, mass, angular momentum and gravitational constant respectively. Then the dimension of E L square by m to the power 5 into G square are first your angle, second option your length, third option your mass and the fourth option your time. So we have to find the dimension of E L square m to the power 5 G square. So see the solution here. We have to find the dimension or unit of E L square to the power m to the power 5 G square, where E is the energy. E is energy, it is given. L is the angular momentum, this is also given. M is the mass of the body and G is the gravitational constant. M is mass of body, G is gravitational constant. Now, so we have to find the dimension of this thing, energy. Dimension of total whole term if we want to find, see, dimension of energy or m L square T minus 2. L is the angular momentum. L is angular momentum as we know. See, angular momentum is given as mvr. M is the mass, v is the speed or velocity, r is the distance. So dimension of L can be written as m, v is the velocity, L t minus 1, r is the again length, ml square t minus 1 can be taken as the dimension of L. So here L square. The dimension of L square means here m square L to the power 4 t minus 2. This is dimension of your L square. Now mass. Dimension of mass capital M, m to the power 5. Now G. Dimension of G if we want to write, to see the relation for F and G. As we know, F is equal to G m1 m2 by r square. F is the mass, F is the force between the two masses. So dimension of force, the dimension of G, dimension of force ml t minus 2, dimension of r square L square, dimension of mass m square. So dimension of G will be your m minus 1 L cube t minus 2. So this is the dimension of G. So now we can put the G square. When we are putting the G square, it become m minus 2 L6 t minus 4. So these are the dimension of all parameters. Now we can simplify. Check it. M cube here, This is also m cube. So dimension of m will be your 0. L square L to the power 4. This become L to the power 6. Here L to the power 6. So this also L to the power 6 and 6 0. Next t minus 2 minus 2 minus 4. T also minus 4. So t also 0. So this is your dimensionless quantity. So ml square m to the power 5 g square is the dimensionless quantity. So in our expression here, no dimension is coming in our options. In our option, first option your angle, second option is your length, third option is your mass, and fourth option your time. So angle is that physical quantity which does not have any dimension. So our correct option is your option number 1. So correct option is your answer 1. Now come to the next problem, question number 14. Question number 14. The question number 14, from the given equation tan theta is equal to rg by v square, one can obtain the angle of banking for a cyclist taking a curve. The symbol have their usual meanings. Then say it is: first, both dimensionally and numerically correct. Second, neither numerically nor dimensionally correct. Third is your dimensionally correct only. And fourth, numerically correct only. See the solution here. As it is given, tan theta is equal to your rg by v square, where r is the radius, g is the gravitational constant, this is your gravity, earth gravity, v is the speed, and tan theta here is the angle. First of all, tan theta does not have any dimension because this is the angle, this is your any numerical value. So tan theta does not have any dimension. So left side is dimensionless quantity. Now right side we will find, see, the left side dimensionless, m0, l0, t0. Right side if we are finding, dimension of r is your L, dimension of g is lt minus 2, and dimension of v square lt minus 1 whole square. So what we are getting here, this also comes as your dimensionless. So what we found, dimension of left part and right part both are equal. So dimensionally it is correct, that's okay, fine. But this angle tan theta, if we have remember, so what we got for the angle of banking is your v square by rg. Angle of banking your v square by rg. So our formula or our relation is not correct. So our relation is not correct, but this is your dimensionally correct. So as per our options, so in the option our dimensionally it is your correct, but numerically it is not correct. So correct option your option number 3. So hence option number your 3 is the correct answer. So question number 14 is this.